Hello friends, what we'll do if you win a 1 million lottery? Just imagine what it would be like. But it's not that hard to win 1 million prize. You just need to solve one problem in mathematics. So there are 8 millennium prize problems in mathematics, and one of them is the Riemann hypothesis, which is related to the distribution of primes. I'm not going to make you clear about this hypothesis. You can search the internet for it. Here I'm not going to describe you about the details of Riemann hypothesis, but I'm just going to discuss on how to check the primes by using a simple intuition of mathematics, by using a simple trigonometry. So I'm not going to deal with the complex logarithm and complex numbers. So by using simple trigonometry, how schoolboy can formulate the formula for primes testing. So before beginning, you must have basic knowledge of primes. These are the numbers that are divisible by the same number and 1, and no any other number will divide these numbers. So let's see what is that simple formula that everyone can create to check the number is prime or not. So we will use the concept of trigonometry. Let's see here, the function sine will give a value of 0 at pi, and at 2 pi also it will give the value of 0, and in 3 pi and so on. So in integral multiple of pi, the sine function will give the value of 0. So we take advantage of this function to create the formula. So to check if 5 is prime or not, we can enlist the number that are below 5. There are 1, 2, 3, 4 and 5. Or being more precise, we can just check if 5 is divisible by the numbers except 1 and itself, or for easier purpose we can exclude the numbers 5 or the number and 1, and the numbers remain will be 2, 3 and 4. So if we check if 5 is divisible by any of these numbers, then it will not be a prime. So what I mean is, you can divide 5 by these numbers 2, 3 and 4, and every time you will get a fraction. So we will use these fractions in sine formula to generate our result. So let's see. Let's keep sine 5 pi over 2. Since 5 by 2 is a fraction, so it is not an integral multiple of pi, so the whole function will give a certain value and it won't give us 0. So 5 by 3 times pi is also not an integral multiple of pi, so it will give some value except 0. Similarly, for 5 pi over 4 also it will give some value except 0. So if we multiply these numbers, this will be some value, and these three will be some 3 different values. So if we multiply them, it's sure that we won't get the value of 0, because neither of them is 0, which indicates that it is a prime. Let's take another example. Is 8 a prime? So we enlist the numbers below 8, that is 1, 2, 3, 4, 5, 6, 7, 8. Being more precise, we exclude the terms 8 and 1, and we divide 8 by these numbers. Unlike the number 5, while dividing 8 with these different numbers, we will get some integer values, like 8 divided by 2 is 4 and 8 divided by 4 is 2, and others remain in fraction. Now let's apply this trigonometric rule. Let's put sine 8 pi over 2, and then 8 pi over 3, then 8 pi over 4, and so on, by 5, by 6, 7, and we will multiply all these terms. So what it results is, when sine takes the integral multiple of pi, it will give us 0. So whenever 8 by 2 value, that it will be 4 pi, that means it is integral multiple of pi, so this will be 0. And if 0 is multiplied with some number, it will give the value of 0. So whenever there is not a prime number, some numbers will be in integral value, so these overall expression will give us the value of 0, which means it is not a prime number. So in conclusion, we can represent this product by the symbol a bigger pi, where the value of k that runs from 2 to 7, so it runs from 2 to 7, and the function is sine 8 pi over k. And similarly, in the above result, we can represent it as the product runs from 2 to 4, sine 5 pi over k. So in more general, what we can say is, if we are going to check a number n, if it is a prime or not, then we can use this formula. So do you have some ideas in simplifying this expression? Because the mathematicians are long working on how to check the primality in the shortest time. The good news is that everyone can create or use this formula to check if it is prime or not, because it uses a simple intuition, the sine function. But the bad news is that though it looks an intriguing formula, but it has actually no use at all in mathematics, because it's extremely difficult to simplify. Because since it is a multiplication, so whenever the numbers gets bigger and bigger, the multiplication terms will get more and more, and it will be more complex to calculate. So what you can understand from here is, suppose for example the person who doesn't know what the trigonometry is will know the primes by this concept. That means if you are going to tell a child if it is prime or not, then you are going to describe this method, because he can easily divide it by the numbers lower than it. But if you know a simple trigonometry and you know this product function, so if you tell your friend that this formula works for checking prime, then he will be amazed by it. So mathematicians have long tried to simplify this method, but what are the problems behind it? So the problems is, as I have already discussed, it's the function that involves multiplication. So whenever there are more terms, it will become more complex. And if you are going to expand the sine function using approximations, but also it doesn't quite work. So just let this formula work, and if anyhow you are able to simplify this function, then it may have some good implication in mathematics. But till then, it's just a representation that a number is divisible by the numbers below it or not. So thanks for watching.